3, 2, 1. Hi, Mrs. Wanamaker. This is my presentation. It's nice to meet you, by the way, about quantum computing. So first of all, we have an introduction quickly to quantum computing. Quantum computing basically bridges physics and chemistry into one. And overall, one aspect that I learned when we looked at like connecting within the course is what like electrons jump from excited and ground state. And that overall helps the process to control qubits inside of quantum computers, which is what we'll talk about later on in the slide. And here's a visual. It is the electron jumping from ground state to excited state and actually from excited state to ground state, and just something we also looked at in the class. And now looking at it from atoms to qubits, so taking it from chemistry level to more of a physical level. Electrons exist in specific states, as we talked about, and this makes them easier to control. And overall, we use these states to be able to control qubits. And overall, qubits are basically the brains of quantum computers, which is something we'll look at more on in this slide. And this overall, with qubits, allows them to solve complex problems. And now we look at bits versus qubits. So bits are something that regular computers use to process, where qubits obviously is something that quantum computers use. And regular computers strictly use 0 and 1 for bits, which we can imagine this as if we take a coin and we put it onto a table and we reference the heads and tails. You can argue that you're only seeing one or the other, as in heads or tails when it's flipped. But then if we look at, say, quantum computers and qubits, and you look at it from an example of taking a coin, flipping it in the air, and imagining it, you can argue that it is heads and tails while it's in the air at the same time, simultaneously, which is exactly what qubits are. They're simultaneously 0 and 1 at the same time. And basically, what I just explained to you was superposition. The spinning state in which the area I just explained is called superposition, and this is what allows quantum computers to solve those complex problems like disease and things like that. That'll come up in the slide later on. Entanglement is another definition that I learned, and that is super important when we talk about quantum computers. And is basically entanglement is basically when you take two particles and they are linked and joined together, even if they are super far apart, which I thought was pretty interesting. And another thing that entanglement tells you is that if you know one particle, then you know the other. So putting that into a real world example, if I measure 1, then I know the other one is going to be 0 because it's the exact opposite of 1. That's what entanglement tells us. That is like a rule. And this overall, like connecting to back what we were talking about, is how it allows quantum computers to work in one massive connected system rather than multiple different parts, like say a regular computer, and overall helps them solve complex problems. And then we can look at this in more of a healthcare point of view, or maybe even a biological point of view. And by protein folding, proteins have to fold in a specific shape to be able to work, and we know that. There are many different shapes, lots of different shapes, for example. And with qubits, they allow us to solve those really complex problems, whereas regular computers, it's just too overwhelming for them. And an example is we know 10 to the 7 like protein shapes, but there are 10 to the 60. And putting that into a healthcare point of view, we can, with a quantum computer, we can easily obtain those shapes when it comes to maybe like a healthcare crisis like liver disease or something, which is something we might see later into our subject. And this goes on to our case study by Dr. Frederick Flother, which he works with IBM, which, as we know, took us to the moon. And they basically teamed up with Rush University, which is a university, obviously, and they did a multi-year study which basically used quantum technology to figure out kidney disease risk in diabetes patients, like the risk. And this overall is an example of how quantum computers can help doctors create specific personal plans and also prevent risk with earlier discovery. And I think that's definitely a really good benefit of quantum computers. And I think, and overall with the conclusion, your regular computers that we talked about that use bits are not going anywhere. They are just perfect and do their great tasks. You'll see them overall in everyday life going forward. But in the future, we hope that quantum and regular computers can work together like they kind of do now, but with further technology, we hope that they become one thing. And quantum technology overall is about using physics to be able to improve healthcare and save people's lives. And I think that was really cool when learning about quantum computers. So thank you for listening.